do we use vibration analysis and what is it all about? Vibration analysis has been used for many, many years in the machine tool industry. Moving components break down. What way can we take information from the vibration that comes out of these units as they're rotating and moving and be able to find out when they're going to fail? When we know a machine is going to fail, we can procure parts, we can have the bearings ahead of time. We're able to make sure that downtime is cut down to a minimum. And that vibration analysis started with yesterday's vibration analyzers. They were very large. They still use what we use today is a very common accelerometer. And it was basically wheeled around the plant in a cart, taking vibration points, trending that data so that they knew, all right, this particular machine, spindle, motor, ball screw is going bad, we need to prepare for it. Just like any evolution, vibration analyzers got smaller, more compact, a little easier to carry. The cart was pushed away. We were able to bring the analyzers on a strap on our shoulder and be able to walk around the plant a little more seamlessly. The old school collection data was just as I mentioned before. A technician would roll up on a cart. This is in a spindle repair lab, but in a traditional plant, he would wheel the cart up to the machine, take his various points of data collection, and then move to the next machine, so on and so on. Today's analyzers basically only have diagnostic capabilities for the immediate operator only, meaning that person in a traditional analyzer of any other type, that person can look at the signature that he is taking a reading on with the analyzer and be able to dictate, okay, I've got an imbalance problem or I have a bad bearing coming up. But he's not able to share that information with anybody because it's locked into the device until he returns back to the office and maybe hooks it up to a computer where he can do further things with the information. Now, today's analyzers are designed for collection data and they download to a PC, and this is what I was speaking of just a moment ago. Once all the data is collected around the plant, generally with traditional analyzer, the technician will download that into a bigger software program because the analyzer itself does not have the software to do the trending analysis that he would want to do over months of time at all the different points around the plant. So he would then take that information, download it into a PC and work in his office to produce his report to his superiors so that they can make important decisions saying, all right, machine number 53 on the B line is looking like we're going to have a failure. We need to plan for it, make sure we have all the components necessary to fix it so we can take care of it on an off shift and get it up and running for production. What we're introducing to you today is how does tablet computing arrives into this and how can we make what I just talked about a lot better. And Apple's iPad is exactly the platform that we chose. It's very seamless, it's wireless, and in the vibration analysis we're going to show you how the touch interface versus a stylus or a mouse or a keyboard is going to really fit well into this program. This is what the analyzer looks all together. I mean, I've got a sample here. This is the finalized case. It's an industrial case. It's got rubber all the way around it. It's sealed from the environment if you were to get oil or some of the messy areas within a production facility. But as you can see, it's extremely portable. The biggest thing with the Apple unit and the program we wrote for it is ease of use. Most people are familiar with Apple's operating system. They call it the iOS. And iOS is just very seamless to use. Most people are already familiar with it. If they have an iPhone or an iPod, most people do. They're in the millions at this point in time. And that's why we chose this platform for the vibration analysis. But it's a very powerful computer too. And that's the other reason why we chose it. It can take this data from an analog form, from a accelerometer, and be able to do all kinds of magic things with it. How do you put this app on an iPad? And GTI, we actually, when we deliver the unit, you already have the software installed. But all of its updates, all of the changes that would happen in the software in the future are all linked through the App Store just like any other application on an iPod, iPhone, or an iPad. The application that we're talking about that wraps the software together for this vibration analyzer is called spindle scope. Here's what our application looks like on the screen in real life. And this is a normal running spindle motor running at 4,800 RPM. And as you can see, you very easily can find the running speed, because in most cases in a good running unit, that should be your highest point. Bearing levels and misalignment levels should never run above running speed. Here's a new rebuild that we did and took a reading of a 75,000 RPM spindle. And one of the things I wanted to point out, this analyzer goes all the way up to 24K hertz, which is 1.4 million CPM. So we cover the whole spectrum of the analysis. It's not just a very small section. On a traditional analyzer, you have to pick, okay, I want to look between 5K hertz and 10K hertz, and that's the window I take the reading in. With this particular analyzer, we're able to take all the way up to 24K hertz, and then just by touch technology we can squeeze our fingers in and out by pinching and look at the area that we're interested in. So that frequency range, you get the whole picture, and then you can hone in on your bearing frequencies, your running speed, so forth and so on. Here's one that's indicative of looseness that I took. You can see the actual running speed is at 4,200 CPM or 4,200 RPM, yet we're getting spike. The largest spike is 3 times running speed. That's indicative of and very common in a looseness situation. That's where this analyzer comes into play. You're able to find out exactly what is the malfunction of the piece of equipment you're measuring. The other thing to look at is, a lot of times something might be vibrating and it might be a simple issue. Very often somebody could put an imbalanced pulley or a imbalanced tool on a component, and it will damage the bearings over time. But with the vibration analyzer and throughout your route, you'll be able to pick up on these things, and you'll be able to know by looking at the signature that, all right, I don't have a bearing frequency issue here, I don't have a bearing problem, we don't have to prepare for failure, we just need to put a balanced tool in this and then we'll be operating properly. This software is very, very robust. We put all the functions of a typical analyzer in there, and in some cases many more functions. And one of the major functions is the cursors. You can pick as many as possible. So when you're looking for those multiples of running speed, which point out misalignment and looseness, when you put your finger on the cursor, because again it's all touch technology, the other cursors will line up and do the math for you of exactly what those multiples of running speed are. Okay, here's one that I wanted to post up also as an indication of bearing defect. Again, we look at a signature. It's very simple. When you have a little bit of training in vibration analysis, your running speed is here at 10,200 RPM, but our highest spike is way out at 145,000 RPM, and the banding around it, that is just a real clear picture of what a bearing defect will look like when you're measuring a motor, spindle, a ball screw, or whatever. You're able to immediately tell that I have a bearing frequency problem. Now you can visit that machine on a regular basis till the repair components come in and make sure that you're not going to have a seizure or failure on the assembly line. Here's another one that I mentioned earlier that, okay, we have no bearing frequencies, everything looks good, no misalignment problems. We just have a high imbalance spike. This is indicative of somebody applied something to a motor, a spindle, or any machine that we're running that was unbalanced. We can quickly cure this problem by either balancing the unit or putting a balanced tool or pulley back on the rotating component. Just to go over a few settings of the features that this software has. You have all your sensor options. You can capture the data and save it in many forms. We're able to adjust our frequency resolution from 1K hertz all the way to, I believe, 100. Your averaging, you can let it run exponentially, or you can just take a peak reading with a 4 or a 10 sample click as well. Also, there's a feature in there if you need to do a demonstration of a problem out on the plant floor, you've just detected a machine that's going down, you can plug the unit into an external screen, which I'm doing with this presentation, and you'll be able to post up on the screen a full image of the vibration levels that you took and all their frequencies so that you can discuss it with your superiors. All the other features are typical of all analyzers. We've got the vertical and the horizontal screen scales. You can go to log or linear depending on what your preferences are, how you like to take your readings. We can measure in hertz or CPM. We can measure in both velocity and acceleration, which acceleration is measured in G's. In velocity we measure in inches per second. Now we can also hit a button and turn on all the spectrum details on the bottom. So we're not just getting a chart and a signature, we're also getting all the top 10 frequencies from the highest amplitude, which hopefully is our running speed, to the 10 next highest, to the 10th highest frequency. We also get an overall reading as well, so that we know these particular machines, we don't like to see a overall vibration level above XYZ number. Now we can quickly go out and do our route and know whether a machine needs to be looked at further or not. The Apple iPad is already connected to the web. It's always connected to via 3G or any Wi-Fi that it may be around at the time. Now when we talk about saving our data, we can save our data in a text file if we want to put it in a more robust software back at our office that might be doing a lot more trending analysis. But we can also save to a PDF graph. So if I've got a problem on a machine out on the floor and it's an important machine and it has a threat of our plant losing production, I can simply save to a PDF document or save the graph to photos, and then I can immediately send that right from the photos from where I'm standing at the machine. I don't need to go to a PC, and my boss or your superiors would have that information at their desk within moments of me taking the readings. Now as I save that data, another option comes up, so I can put in all the data that I'm referencing this reading on. You know, what type of machine is it? What serial number is it? Where is it on the floor? It gives quite an unlimited amount of text, and that text will be bulleted and documented at the bottom of the report. So you're really getting a nice robust report when you take this reading and save it to the images, and if you save it to a PDF file. Now again, we're web connected. So if we don't know, we're on the floor, we're taking a reading, we see something strange, or we're not as trained as we would like to be, we could simply go to the web and go to vibration reference guides, severity charts. Those are all on the web. All you have to do is go to Google, punch in, this is what I'm looking for, and now you've got it on the same device that you're taking your measurements with. Here are a few more vibration reference guides. You know, they're very plentiful on the web. Also, got a few bearing people here also that you can tell, you can, after you do your analysis, they take the device apart. Now you can start from the same device. We're looking at different failure analysis and failure causes of bearings. Also, we can find out while we're measuring something, all right, well, we don't know what bearings are in it, or we can find out what bearing is in it. We can call the OEM, email the OEM from the device, pull up their website, get what bearing or component is inside that we're measuring, and that allows us to go to another website that allows us to put the speed in, and now all of a sudden we've got our defect frequencies are printed out for us on the bottom, and now we're able to know exactly, going back to the chart, if I have these frequencies, I have a bearing defect. There's no more guessing. It's there. It's in front of you. Again, more severity charts. You know, a lot of people say, oh, I can do vibration analysis, but what's good? What's bad? Well, there are charts on the web that you can pull up, put right on the screen, and it will tell you based on, you know, what you're running, whether it's a drive motor or a very precision spindle, or is it a ball screw? Where does it fall in the severity chart, and where should I be not exceeding the readings? All of our contacts are in there. PDF files and iBooks. All your manuals for your machines, they're at your fingertips. I can go directly from the iPad and go to my computer and operate my computer. Finally, emailing. Also, I don't have to go back to the office to send out a critical email. Location. That's another important thing. All right, we need XYZ part for this machine. We simply go to the next app, which is our map app. We put Motion Industries in there. Where's the nearest one? Where can I get to get this part and get this machine up and running? And then finally, even keeping in touch with entertainment, the flights you take, it has it all. So this is why GTI has picked this device to work on. It covers everything from A to Z.